All right, so one of the earliest applications we deal with derivatives and slopes is about rates of change. And rates of change are changes. And in math, you would have, in prior algebra classes, rate of change would have just been the slope. But you think of the rate of change as like some kind of slope. Now, average rate of change is a secant line slope. 2 points, f of b, the difference in the y value divided by the difference in the x value. It's the slope between 2 points on the curve or a function, and generally the x variable is time. Doesn't have to be, but very often it is. Instantaneous rate of change, though, is the slope of a tangent line, right? So that is the derivative here. So you got to think about the instantaneous is the rate of change right at that particular moment, at that particular point on the curve. An average rate of change is over 2 points. And a lot of times you're interpreting what the derivative represents. It's the rate of change of the y variable divided by the x variable quantity. So if you're given, and we'll go through some examples here, but like whatever variable is given there, it's going to be the change in that y variable divided by the change in that x variable. And the x value is when that rate of change applies, over the duration. So for an average rate of change, it's over a period of time because it's between 2 points. Instantaneous rate of change is at one particular moment in time because it's at a specific point, not over like a range of a couple of points. Okay, so we'll go through some examples just to clear up what that means. So given this function, let's find the rate of change from 1 through 5. Okay, so then this would be f of 5 minus f of 1 over 5 minus 1. It would be that secant line slope. And average rate of change is always going to be given by an interval. So you're going to plug in 5 in here to get f of 5. That minus, and then plug in 1, 3 times 1 squared, minus 2 times 1, all divided by 5 minus 1, right? And so then that's going to be just a number. Let's see, 75 minus 10 is 65. This is going to be 3 minus 2, which is 1, and then that's over 4, and that's going to be 64 divided by 4, which is 16. This one had no unit, so we don't have to put any units, but we'll go through some problems where we have some. How about the instantaneous rate of change here? That would be the derivative, the derivative at 4, right? And so that's going to be, first let's do f prime of x, derivative of this. Just use power rule. It's going to be 6x. Derivative of minus 2x is minus 2. And then when we plug in 4, we're going to get 24 minus 2, which is 22 there, right? Just plug the 4 in for that x. Okay, let's look at something with terminology so we can talk about interpreting what these rates of change represent. What is so let Q of T represent the number of products sold on Amazon.com at a given time, where T represents the number of hours after 12 p.m., e.g. T equals 0 refers to 12 p.m. What is the interpretation of Q of 6 minus Q of 1 over 6? So it is the average rate of products sold per the x variable. The y variable is number of products sold. The bottom variable is time, and their number of hours per hours. It's the average rate of products sold per hour. So not per hours, per hour. Between what times? T equals 1 would be 1 p.m. T equals 6 would be 6 p.m. 1 p.m. and 6 p.m. Okay. What's the interpretation of Q prime of 3? It is the rate of products sold at that particular time, sold per hour at 3 p.m. Okay, so this is at a particular time. This is over a range of times. That's the difference between the average rate and instantaneous. You don't have to like say instantaneous in your answer here. You can say instantaneous. Okay, instantaneous. Yeah, okay. I don't know. I didn't spell that correctly. Whatever. Just because you're saying at a particular time, right? Interpreting, that's what that means. Okay, let's look at a multiple choice question here. The cost in dollars to paint x square feet of house is modeled by the differentiable function c of x. Which of the following best interpretation of c prime? Okay, so c is cost. X is the square feet. So it would be dollars per square feet. Okay, that's the units because the y variable is going to be the dollars, right? So that's a function. And the X variable X here is in square feet. So dollars per square feet. And it's going to be when X equals 300. When this is 300, right? That's at that moment in time. It's not a moment in time. It's at when the house is at 600 square feet. So the cost of painting, blah, blah, blah. When 300 square feet have been painted, the cost to paint the next square foot is approximately $6. This is the best answer because you want to talk about at 300. The problem with these, the cost of painting 6 square feet is $300. One, the 300 it was the number of square feet. Cost of painting 300 square feet is $6. That's not the case because this 6 is the cost for the derivative, right? Like this interpretation is C of 300 equals $6 or something like that. But that's not what they're asking. This is a C prime here. It's a derivative there, right? So it's not that one. Cost of painting 300 square feet is $6 per square foot. So this is the correct units. This one's tricky. It has the correct units, $6 per square foot. But it's not per square feet. It's the rate. It is the rate at which you're doing. Not for all 300 of those square feet, but when you are at 300. That's why we say when 300 square feet have painted. That's saying at X equals 300. Then the cost is this. And the cost is dollar per square feet. In other words, every square foot would then cost $6 at that particular point.